Plate Motion Unit Lesson 3.4, Writing about Mesosaurus. Activity 2, Examining Evidence about Plate Motion. Here's what your student screen looks like for this part of the lesson. Chapter 3 question, how did the Mesosaurus fossils in the South American plate and African plate get so far apart? We've learned more about how Earth's plates move. Evidence of geologic events and landforms helped us identify that the plate boundary we're looking at is divergent. Now we'll consider all our evidence to answer the Chapter 3 question and explain how the Mesosaurus fossils got separated. We want to be able to advise the Museum of West Namibia on how to explain to museum visitors how the Mesosaurus fossils got separated. These are the two claims you'll be addressing and writing about at the end of the lesson. Plate motion claims. Claim 1. The South American plate and African plate moved apart suddenly. Claim 2. The South American plate and African plate moved apart gradually. Today we'll be examining the evidence that we already gathered as well as some new evidence. This evidence will help you think about the Chapter 3 question, how did the Mesosaurus fossils on the South American plate and African plate get so far apart? It will also help you write a complete scientific argument supporting one of these claims when you write to Dr. Moraga later today. Before we begin writing our scientific arguments, we'll review the evidence we have collected about plate motion and record any notes that help us better understand the evidence. This will help prepare us for writing our scientific argument later. Students, take a minute or two to review the evidence and record notes. Plate boundary evidence map. We've been gathering the evidence shown on this map throughout the plate motion unit. You use this evidence to identify the plate boundary between the South American plate and African plate as a divergent plate boundary. Use the map to review the following pieces of evidence. A. Earthquakes occur in a pattern along the plate boundary between the South American plate and African plate. B. A mid-ocean ridge landform is found along the plate boundary between the South American plate and African plate. C. Volcanic activity happens in a pattern along the plate boundary between the South American plate and African plate. Remember, all the Mesosaurus fossils lived about 300 million years ago, and the entire population once lived in the same place. Mesosaurus fossils are now located on different continents and are separated by an ocean. Here's what your student screen looks like for this part of the lesson. Let's review evidence card D. How do you think this additional evidence is connected to the claims about past plate motion? Students, read evidence card D. The continents of South America and Africa, where Mesosaurus fossils are located, are currently about 4,000 kilometers apart and separated by the Atlantic Ocean. GPS measurements show that the South American plate and African plate are currently spreading apart from each other at a rate of 3 centimeters a year. Geologists use evidence about patterns of plate motion today to inform their thinking about how plates moved in the past. How could this evidence about the current distance between the continents and the current rate at which the plates are moving away from each other at the plate boundary help us understand past plate motion in this area? Remember, rate is how often or fast something happens. In a year, these plates move about 3 centimeters apart at the boundary. 3 centimeters per year converts to a rate of 30 kilometers per million years. In other words, in 1 million years, the plates have moved 30 kilometers away from each other. Evidence card D lets us know that the distance between South America and Africa is about 4,000 kilometers. If the plates move away from each other at a rate of 30 kilometers per 1 million years, how long would it take for them to travel 4,000 kilometers? You may wish to have scratch paper and a calculator to make this calculation. This calculation predicts that it would take about 130 million years for the plates to spread apart 4,000 kilometers, based on the current rate of plate motion. Mesosaurus fossils are the remains of organisms that lived together when these continents were parts of one giant supercontinent. In the first lesson of this unit, we read, the earliest fossil evidence for these animals indicates that they were alive about 300 million years ago, and their species went extinct about 260 million years ago. We just calculated how long it would take for the plates to separate 4,000 kilometers, which is how far apart they are now. We also looked at how long ago the Mesosaurus fossils lived and died out. With your partner, discuss evidence card D. Has enough time passed for the Mesosaurus fossils to be separated as far as they are now? Why or why not? focusing on the timing of when the Mesosaurus fossils lived and the current rate of plate motion, remember that you may make notes about the evidence card, adding ideas from your discussion if you wish. What ideas do you have about the evidence on evidence card D? This evidence shows that the plates are currently moving away from each other very slowly and that there was enough time for the fossils to be separated by 4,000 kilometers based on the current rate of plate motion. End of activity. Be sure to complete all your student work and amplify for this activity before moving on.